Hardware hipsters, it's Prof G. Are you prepared to become dashboard dynamos controlling your Raspberry Pi Pico W over the internet from an easy-to-create web dashboard? Well, if so, you're in the right place, because in this lesson we're going to learn to work with multiple controls and feeds. We're going to build on the on-off toggle that we used in our prior lesson to turn a NeoPixel strip on and off. We'll add a color picker so that we can change the NeoPixel strip's color. We'll add buttons that can play sounds, and we'll use a slider to move a servo motor. If that sounds good to you, then let's learn big. Now, just a quick reminder for anyone who's new here. In our prior lesson, we set up a free Adafruit IO account, and we wrote preliminary code to connect to Adafruit IO and turn a NeoPixel strip on and off. I'm going to assume everyone's already done this, and we'll begin by modifying code that we wrote in the last lesson. If you haven't done the prior lesson, find it in one of our playlists, and when you're done, come back here. And hey, I need you. I'm trying to reach as many people as I can with these completely free, high-quality university lessons. The only way I can do this is with your likes, comments, and subscribes, goosing that dogmatic YouTube algorithm to know this content is worthy of its recommendations. Please help me out. Tap that like, drop a comment, give a sub, and more free university goodness, which we charge tens of thousands of dollars for if you're in person, will be on its way. Once you've done that, kind person, open your browser, head to io.adafruit.com, make sure you're logged in, and click on the Dashboard tab and pull up the remote control dashboard that we created in the last lesson. Let's start by adding a color picker. To do that, click the New Block button. Find and click the color picker block, and you're asked to select a feed or create one. We're going to create a separate feed for our color picker. If we use the same feed as the feed for our on-off button, Adafruit IO would reset the toggle switch to off each time we selected a new color, and we don't want to do that. But creating a separate feed for our color picker will prevent this, and it will treat the controls as separate. So to create a new feed, just click in the field that says Enter New Feed Name. We'll call ours color_feed, all lowercase, all one word, and press Return. And we see that new feed name now appears in our list of feeds. Click the checkbox next to the color feed and click Next Step. And that'll attach the new color feed to our color picker control. Let's add a block title. NeoPixel strip color is a good title for this block. And then we can click on Create Block. And since we've never used this before, we don't see any color in the block, but it's now on our dashboard. Now let's head over to our CircuitPython program and add code to receive messages from the color picker. Now, I saved the file at the end of the last lecture. We use the name Adafruit_dashboard.py. If that code's not already in your editor, make sure you grab that from your CircuitPython school folder and paste it into code.py now. And I'll change the first comment to the name. I'm going to save this as multicontrol_Adafruit_dashboard. Now, in this block of code where I work on my NeoPixel strip, I'm going to create a variable that I'm going to call strip_color, and I'm going to set that equal to all caps red, this color that I created up here, and that's going to be a global value to hold the current color. When we use the color picker to change the color, we're going to update strip_color. Then we'll create another variable like this one here that contains the string where we're going to find our new feed, the color feed. So I'll just highlight this line, copy it, paste it below, and on this new line I pasted in, I'm going to change the name to color_feed, and this feed string here will be /feeds/color_feed. That's the name that I gave the feed in Adafruit IO. Now, once I've set up this feed string, I want to use it to subscribe to that feed. So down here in my connected function, below where I say client.subscribe to strip on-off feed, I'm going to say client.subscribe, and in between parentheses, I'll pass in color_feed. So we've just modified our code to subscribe to the dashboard's new feed. So now we've got this set up, we should be getting messages from that new feed, the color feed, as well as our strip on-off feed. Now let's modify our message function here so that we can respond to messages coming from our new color feed. First, what I'm going to do, since I'm going to modify our strip color in here and update that with the newly selected color, is I want to specify that our strip_color variable that I created above is a global variable. So I'll just put in global strip_color. If I didn't add this global line, then my code would have ignored the earlier strip color value that I created, and when I refer to strip color inside this function, it would think that that was a new variable local to this function, and that would get wiped out each time the function's done running. If that happened, we wouldn't be able to keep track of the strip color each time we had a new message come in. Now, previously we didn't look at the messages feed because we only subscribed to one feed, so we knew all messages were coming in from the strip on-off feed. But now we've got more than one feed. So whenever the dashboard publishes a message, if we've subscribed to the feed of that message, then this function is going to be called. And we get the feed name and the topic variable up here, as well as the message that's sent by that feed. So we need to check the topic value to see which feed the message comes from. And then we can respond to the message we expect from that feed. So before we check to see if we have an on or off message, let's add a line that says if topic double equals strip underscore on underscore off underscore feed colon, and I'll highlight the 5 lines below and I'll indent them 1 level by pressing the tab key, and these lines will now only execute if we get a message from strip on off feed. Now I'm going to make a change in how I handle on-off. Instead of changing color from red to black, I'm going to set the brightness to full brightness or 0 brightness. So in this if message double equals on block, I'm going to add a line down below that says strip.brightness equals 1.0. And in the else block below that, I'll add a line that says strip.brightness equals 0.0. That turns the strip off. And since I might change my color using the color picker, I don't want to fill the strip with red each time I turn it on. Instead, I want to use strip underscore color, my global variable. Now this is going to be red when the code first runs, but we'll update this variable in just a bit so that it changes each time we select a new color from the color picker. So up here, I'm going to write a comment that says on/off toggled. And now that I'm turning the strip off using brightness, I no longer need this line where I fill a strip with the color black, so I'll highlight and delete this. Now below this, I'm going to outdent so that I'm at the same indentation level as the if topic line above, and here I'm going to enter an elif statement, checking to see if topic double equals color underscore feed colon. If that happens, a message was sent from the color picker was used. Now, just as an extra safety check to make sure that I'm getting a color, indented in the line below this, I'm going to write if message bracket 0 bracket double equals, and then the string, so between double quotes, the number sign or hashtag. Make sure this line has a colon after it. Now, we don't absolutely need this line, but it's sort of a safety check for us. Colors are sent from the color picker in hex format. That's base 16 format, and the first character in that value the color picker sends is always a number sign. The number sign means base 16. So by checking to see that a number sign is in here, we just double check to make sure that we got a color value, which we should. Now this value we're receiving is going to be a bit of a problem. It's a string and a base 16 number, a hex value. So we're going to convert it to a number, and the easiest thing to do is to convert the hex inside the string to a base 10 decimal value. And once we do that, we can change our color using the value that we get. And here's how we do that. We'll first remove the number sign from the first character in the string in the message. We're going to do that by saying message equals message square bracket 1 colon close square bracket. Now characters in a string are 0 indexed. So 0 is the first character, 1 is the second character. And this notation says start with the second character, that's at index 1, and the colon with nothing after it says go to the rest of the string. So again, that just removes number from the string. It sets message equal to the character at index 1, which is the second character, all the way through to the end. Now we can use a hex value as a color. The problem is we don't have a hex value here, we have a string, and there's no easy way to convert a hex value in a string to a hex number. But we can convert a hex value in a string to a base 10 integer using just a single line of Python code. So we'll do that here. We're going to set strip underscore color, our global value that holds the current color, equal to int parentheses, message comma 16, close parenthesis. So this takes the string in message, states that it's a base 16 value, and it converts it to an integer, which is a base 10 value. Then all we need to do is say strip.fill, and in parentheses pass in strip underscore color. So this works great. Again, we verify we've got a hex value, we strip out the number sign, we convert the remaining base 16 value that's in a string to a base 10 integer, and assign that to strip underscore color, and use that value to fill in the strip. So this should work. Let's open the serial console and save, and we connect to Wi-Fi, we connect to Adafruit IO. So let's head over to our web dashboard, and if we toggle on, the default color is red, so we see the strip in red. But now let's click the color picker so we can select a color range on the right hand side. So I'll select blue, and then I'm going to click and drag on the square in the center here and select this blue and click save, and look at that, we're blue. Notice the hex value shows down below. I'll click the color picker again and use the slider on the right. Let's select green this time, click save, and we're green. Now if I click off and then on again, we can see we're still green, but I can also click off and then change the color to say pink. Click save, and then if I turn the strip on, the strip is in pink. Nice! Color picker working. Now back to our code. And by the way, we can see in the console the topics, which are feeds, are printing out for each message, and we also see the messages that are sent as well. On or off each time we click the toggle, and we see a hex value each time we change the color. So this is great. I'll close the serial console, and I'm going to save this to my CircuitPython school folder. We've got the name in the first comment, and we'll close that at our Most tab. Now we're going to add buttons on our dashboard to play sounds on our PicoW. But in order for this to work, we need sounds. You can use any MP3 sounds that'll fit on your board, but I've already got some that you can use if you'd like. If you want to, you can open a browser, head to the open Google Drive at bit.ly/circuitpython-school-files, all lowercase. Find the folder named Sounds. I'm going to double click this and open this folder, and I'm going to highlight both encouragement1.mp3, not .wave, those will be too big, and encouragement2.mp3. On the Mac, you can option click to select multiple items at once. Then I'm going to right click and select download, and I'll download these items to my computer. Now I'm going to put both of these files in a folder named Sounds, all lowercase, and I'm going to drag the Sounds folder onto my Pico. If you don't have enough room on your Pico, you can delete any files you don't need, like any existing old sound folders that are on there. So your Pico should look like this with the Sounds folder with two MP3 files, Encouragement 1 and Encouragement 2 inside of it. Now let's head back to Adafruit IO's dashboard and add buttons to play these sounds. And remember, to add a new element to our dashboard, we just click New Block. Find and select the block that's called Momentary Button. That's just a push button. That'll bring up this box that says Connect to a Feed, and we're going to enter a new feed down below. In this box, we'll say Sounds_feed. We'll press Return. Then you can click the checkbox next to that new feed and click Next Step. Let's add button text. We'll call this code or code not. And for press value, I'm going to enter the name of the file that I want to play. And it's okay to go and copy it right from your desktop if you'd like. I want to play Encouragement 1 here. I'll paste it in. That just ensures I have no spelling errors. So the full name and extension should be in here, encouragement1.mp3. So when I press this button, the message encouragement1.mp3 is going to be sent over the feed. And when I release the button, a 0 is going to be sent over the feed. I'm going to ignore the release value. I'm not going to do anything when the button is released, but we need to have something in here. Then I'll click Create Block. And now let's add another button for another sound, so we'll click on New Block. This is also going to be a momentary button. This time I don't need to create a new feed. I'm just going to reuse my sounds_feed, so click the checkbox next to that and click Next Step. The button text for this one is going to be Code Monster, and I'm going to paste in the same sound name as before, but I know instead of it being called Encouragement 1, this one should be Encouragement2.mp3. So I'll change that. Again, you need to spell the name in here exactly as any sounds in your sounds folder. Then I'll click on Create Block, and the buttons are at the bottom of the screen. I'd like to move them around. I'll click on Edit Layout, and you see the buttons now have a border around them. This lets you click and drag or move any interface elements around your dashboard, and if you move your cursor over an element, it'll turn to a plus sign with arrows around it, indicating that you can click and drag from here. So I'm going to grab this first button and move it to the upper right, and unfortunately the web layout is really fussy. Watch what happens if you drag one element over another. Now I haven't released my button yet, but the color picker jumps down below. That's okay, we'll move it back. And I'll put this button over here to the right of the toggle, and I'll grab the Code Monster button and drag it up, but you can actually lay things out any way you'd like. The border in the lower right corner of any element is a bit thicker, and this indicates that it's a resize handle, so you can click and drag to resize an interface element. And now I'll drag the color picker up just below the toggle, and I'll position the buttons, and instead of side by side, how about one on top of the other? And when you have things the way you want, you can just click Save Layout, and your adjustments will be saved. Now let's head back to our code. So I'm just going to change the comment up here to read color picker and sound, and then I'm going to add the code to play MP3 files on a Pico. And we've had lessons on MP3 playback, so I'm not going to go through this code in detail. If you've gone through the entire course, you should be familiar with the code we're about to write, but if you need to go back and check that out, the playlist has lessons on MP3 audio playback. So I'm going to grab this code from our CircuitPython tip sheet. That's at bit.ly/CircuitPython, capital C, capital P, -tip-sheet. Command F on Mac, Control F on Windows, and search for MP3. And here's the code for the MP3 code, but let's get the setup code for the Pico first. That's this code here that says setup for the Pico, so I'm going to highlight and copy this. Head back to my code, and I'll paste it up top just below the import statements. Then I'll grab that MP3 code from the tip sheet and copy this. Head back to the code, and I'll paste this below the audio out object that I just created. And I'll cut out this MP3 decoder statement. And I'll paste it over this import for the WAV file. I'm not using WAV files here, just MP3s. I'll clean things up. Our path is named sound, so that's good, but we need to change the file name in here. Remember, whenever we set up MP3 playback, we need to create something called a decoder, and to do that, we need to pass in the name of a valid MP3 file that's stored in our CircuitPy volume. So I'm going to change the file name in here to read encouragement1.mp3, and this is all looking good. But I am going to make a change to the play MP3 function that we have here. In the past, we've said while audio.playing, and below this, either we say pass to hold on until we're done playing the audio file, or we'll call another function within this while loop if we want another function to run while the sound is playing, but then to stop when the sound is done playing. We've done this, for example, when we've pulsed lights only when a sound is playing. And I'm going to cut out while audio playing pass, and this is why I'm going to do that. This is going to continue to play the file, but we're going to fall through and we're going to continue to accept any additional updates, meaning incoming messages that might come in from the main loop. So this will let us do things like turn on or turn off the NeoPixel lights while the sound is playing. Cool. So we don't need while audio.playing in here. We just need 2 lines inside of this function, and that's it. Now, before we write the code to play sound, let's make sure that we're going to receive messages from that sounds feed that we created. So I'm going to add a value down here. We'll create a sound feed. I'm just going to copy my color feed and place it down below, and I'm going to replace color_feed with sound_feed in the beginning as the variable name and also within the string. And now we also want to make sure that we subscribe to that feed. So as the last line in the connected function, we want to say client.subscribe, and in between parens, pass in our sounds_feed. Again, really important to make sure that you've got the spelling correct here. So notice that I named my feed sounds plural. So you want to make sure that you use that in any strings. If I spelled my feed wrong, then I wouldn't be reading in any messages from that feed. Then down inside the message function, we want to add another condition to our if statement to check to see if we get anything from our sounds feed. So below all the code from the elif topic double equals color_feed, I'm going to outdent so that I'm equal with the if elif for both of my topic checks. And I'll just say elif topic double equals sound_feed : if that happens, the button has been pressed to play one of the sounds. And then indented below this, I'll say if message exclamation point equals, which means not equals, the string 0 : now remember, those buttons send a 0 when you release the button, and we don't want to respond to any button release messages, so we're just going to ignore those. So if the message is not equal to 0, then we want to play that message. Indented below this, we'll just say play_mp3, between parentheses, we'll pass in message, and that's it. We can open the serial console, click on save, and it looks like we're connecting to Wi-Fi. We've got no errors. We've connected to Adafruit IO. Let's head to our console, click code or code not.
Code or code not. There is no try.
Code monster.
Code monster.
There's some Yoda encouragement. Let's turn on our light strip. We'll set a color. Always make sure you click on the middle square, click on save. Light's still lighting up in blue. If you click the button while another sound is playing, you'll hear one sound overwrite the other.
Code or a code monster you have become. Code or
So
code
all this
not.
is looking good.
There
You can
is
try
no
out some of
try.
these options, but we've got
Code
sound
or
playing, a
code
color
not.
picker,
There is
and
no
our
try.
toggle on
A
off for the
code
light strip.
monster you have
Nice.
become.
Now notice in the serial console, we wrote our code to print out the topics, which are the feeds and the messages that are sent, so we can see the name of the MP3 files we're playing, as well as these zeros that are coming through. Remember, the dashboard sends a 0 when we release the button. We're ignoring those. We've still got our on-off toggles. We've got our color hex values, so this is looking good. I'm going to go ahead and save this to my CircuitPython school folder. I'll call this color picker and sound. I should probably have put MQTT in the name, and close that outermost tab. Let's finish this up by adding one more dashboard control, a slider, and we'll use this to control a servo. So let's head back to our Adafruit IO dashboard in our browser, click New Block, and this time we're going to select Slider. We're going to enter a new feed down below called Servo_feed, press return, then click on the box next to Servo feed and click Next Step. I'll give this a block title of Servo Angle. I'll keep the slider min value as 0, but I'll set the slider max value to 180. That's because standard servos swing from a 0 to 180 degree arc. I'm going to change the slider step size to 1 so that I can change the slider values 1 degree at a time. Over on the right, you can slide the preview to test it. You can leave the slider label empty, but I'm going to get fancy-like, and I'm going to hold down Shift-Option-8. That types the degree symbol on the Mac. And I've not seen decimal places do anything. That's probably because I'm not incrementing by decimal values in here, but I'm going to make this 0 anyway. Then click Create Block, and we see the servo angle slider is created down below. Now, if I want to move this, I can click Edit Layout. And if I drag it out wide so that it doesn't touch any of the other items, they won't jump around and I won't have to readjust things. And I'm going to place this below my 2 buttons, then click Save Layout. And now let's add some code to make this work. And I'll change this first comment to read MQTT dashboard color picker sound servo.py. And again, if you're new here, you need a refresher. We covered servos in depth in an earlier lesson, which you can find in the playlist if you want to go back and check that out. So since we covered servo code in an earlier lesson, I'm just going to head back over to our tip sheet and do a search to find servo. I'll highlight and copy this code, return to my editor, paste it below my import statements. And I'll get rid of this initial servo angle, and this code was written for the circuit playground. I'm going to change the pin we're using for our servo to board.gp13. I've already got values for min pulse and max pulse, but remember, you can change the shrinking min_pulse if you need to lower your zero angle, and increase your max pulse if you need to push your 180-degree angle out. Again, I discussed what all this is about in our lesson on servos. Then we'll start out with servo_1.angle, setting that equal to 0. Then down below, let's set up our feed. So I'm just going to copy my sound feed and paste a copy down below. And I'm going to change the name to servo_feed. And I'll also paste servo_feed into the string. And then down below in our connected function, I'll say at the end client.subscribe. And in between parentheses, I'll pass in servo_feed. Then down in our message function, remember this is where we respond to messages, we need to add another elif for the topic of servo feed. Make sure that you outdent so that this is even with the indent level of the other if-elif statements for topics. And I'll say elif topic double equals servo_feed. If this happens, the slider's been moved. And to make this move, it's super easy. So indented below this, I'm just going to say servo_1.angle equals int, and in between parentheses, message. Remember, message is a string, so I've got to convert it to an int, but that's it. Let's open the serial monitor, click on save. Looks like we're connecting to the internet and Adafruit IO, so let's head over to the dashboard. Let's slide that slider, and oh, look at the servo move. Slide it again. Look at that move. Your servo is swerving. We can still change colors over here with our color picker. We can play sounds and move the servos while the sounds are playing.
There is no try.
CircuitPythonista, that is some masterful MQTT work.
A code monster you have become. Skilled you are.
You are a code monster. You are skilled. Now, there are two short things that I'd like to show you before we finish this lesson. First, the servo is sweeping in the opposite direction of the slider. Unfortunately, at this point, you can't set the slider value to swing from a high number to a low number, but we can move the servo in the same direction as the slider. We'll simply change the servo angle to 180 minus the set message angle. What that does is it just changes the direction so that whenever the servo angle is 0, we're really going to be at 180, and whenever we're at 180, we're really going to be at 0. Simply moving the servo in the opposite direction. So now I'll save and return to the dashboard, and I'll put the slider somewhere in the middle. Then if I slide to the left, the servo goes to the left. If I move it over to 180, the servo moves to the right. So it's now moving in the exact direction as the slider. Nice. Mission accomplished. There's one other thing that I'd like to do. If I unplug my Pico and I plug it back in, I'd like to get the latest settings from the dashboard and use those settings to move my servo, to set my colors, and to turn my strip on or off. And it is possible to do that, but we're not doing that right now. Watch what happens when I unplug my Pico and plug it back in. The default code has the strip lights off and the servo moving to the 0-degree position, but my dashboard has the strip on. It's got this greenish color and the servo angle's at 127. Well, let me show you how we can grab the latest values from our dashboard and use those in our code to change the settings in the hardware that's connected to our Pico. So let's head back to our code. And when we look at our feeds, when I turn on my Pico, I want to get the last value that was sent to strip on off feed. That's that on off toggle button. I also want to get the color feed. That'll be the value from the color picker. And I want to get the value of the servo feed. So I want to get the servo angle. I don't care about the sounds because I only want to play sound at the moment that the sound button is pressed. But let me show you how we can get the latest value from these three other feeds. Let's scroll down just before the while true loop. So after we call MQTT client.connect, we've connected to our broker. Remember, that's Adafruit IO. And then we're going to tell the broker, I should have written broker instead of dashboard, to send the latest settings from these feeds. So we're going to say MQTT_client.publish. Up until now, we've only subscribed to feeds, but now we're going to publish. And in between parentheses, we're going to say the name of the feed that we want to connect to. So I'll start off with strip_on_off_feed. And to tell Adafruit IO to give us the last value that was published to this feed, we're going to add a string, so plus double quotes, /get in lowercase letters to the feed name. Close double quotes, comma, followed by an empty string, so two double quotes in a row, followed by a closing parenthesis. So what we're doing here is we're publishing a message to the feed name, but we're appending /get to that feed name. It doesn't matter what we send, but we publish this back to the broker, Adafruit IO, and the /get with the feed name tells the broker to send back the last message that was published to this feed. So I'll copy this line, I'll paste it 2 times below, then I'm going to change the second feed to color_feed, and this third one to servo_feed. That's it. So now when I save my code and I connect to the server, next we're going to publish these 3 messages, and we should get back 3 messages that include the last values that were set on these 3 separate feeds. Those should be the settings in the dashboard for that strip on/off toggle, the color picker, and the servo angle. When we receive each of those messages each time, our message function is going to run and it should update our hardware. So I'll put a reminder comment in here. Publishing to a feed with the string /get added to the feed name will send the latest values from that feed. For us, that was the latest settings that were published by our Adafruit IO dashboard. And you know what? Before I save this, I'm going to scroll up, and right when I set up my servo, I'm going to set its initial angle to 180 instead of 0. But this is going to matter less because we're going to get the current value of the angle from the slider. So let me save this. The servo angle initially moves to 180 and we have our lights off. It'll take a second to publish those 3 messages and get 3 messages back. But look at that. The Pico's been updated. The lights are on. The color's this greenish yellow. And the angle of the servo is set to 127 degrees. Outstanding. Now my dashboard continues to control my Pico, but now I'm going to unplug my Pico. And with the Pico unplugged, I'll change some settings. I'll set the color to magenta. I'll turn the light strip off. I'll set the servo angle to 180. Then I'll plug it back in, and we should see that after the Pico starts, it publishes the get message to Adafruit IO, and it'll get the latest setting for the color, the light strip toggle, and the servo angle. And there it is. Now we turn the light strip off, but when we turn it on, it should be magenta, and it is. So Pythonista, this is pretty sophisticated work. You've got a web dashboard, you're sending commands over MQTT, they're being received by the subscribing CircuitPython program. When the code starts, you also publish a request to the server to get the latest command so you can update the hardware. So let's save this MQTT dashboard, color picker, sound, servo to our CircuitPython school folder and close out that external tab. Feel good about those mad MQTT skills. There's more coming, including robot building. Continue to hack.